of Arts and Commerce. This is SST Edupedia and myself, Assistant Lecturer AShwati Prashant. Today we are going to discuss about a very interesting topic of chemistry subject. So, today's topic is solid state. Now, what is solid state? As we have already discussed about the state of matters, we have learned many things about it in the previous classes. So, there are three states of matter: solid, liquid and gas. So, when we see about a gas molecule, then we will find it that gas molecule have spaces, very huge spaces between the atoms. So, we can't see them clearly with our eyes. Now, when we talk about the liquid molecules, we know liquid molecules are compactly arranged as compared to gases, but still some spaces are there in the liquid molecules or atoms. Because of that only they are volatile. They can take shapes of any container or anything. Now, when we come on the solid molecules, we all know solid is hard matter. It means atoms are very compactly arranged in the solid molecule or the solid matter. There are least spacing, or we can say there is no spacing between the atoms of any molecules. Now, what is solid? So, we can know more about the solid on the basis of some characteristics and properties. So, first, definite shape. As we all know, all the solid has definite shape. We can see with our eyes them, and also we can touch them. They are hard. Second, definite volume. All the solid has a perfect definite volume or the mass. All are measurable. Then third one is highly incompressible. All the solids are highly incompressible. We can't compress the atoms. Why? Because they don't have spaces between the atoms. So obviously there is no spacing to compress atoms or to make them move from here and there, from their position. They are rigid. Rigid means they are hard and they are stiff. Obviously, atoms are compactly arranged, so they are not able to move even an inch. Next is constituent particles held closely by strong intermolecular forces. Now, one question arises: why solid atoms or molecules are so compactly arranged? So, there must be some reason behind that, and this reason is the strong intermolecular force of attraction. All the atoms and molecules exhibit some strong forces between them. Because of that force of attraction only, they are situated at one place and compactly arranged. Last but not the least, fixed position of constituents. As there is no spacing between them, also the intermolecular forces of attraction is between the atoms and molecules. So all the atoms or unit particles are compactly arranged and they are situated, they are acquiring a fixed position. Now, after knowing something about the solid, let's come upon the types of solid. So, on the basis of atomic arrangement, binding energy, physical and chemical property, there are two types of solids. One crystalline and second one is amorphous. So, let's talk about crystalline solid. Now, what are crystalline solid? As we all know that solid has some crystal structure. These crystal structures make different types of forms of solids. So, the building constituents arrange themselves in regular manner throughout the entire three-dimensional network. Existence of crystalline lattice. Now, as we know, in the solid, all the constituent units are acquiring a fixed position and there are no spacing. So, on the basis of that, we can say these crystalline solids are the solids in which these units are arranged in a perfect particular manner. So they are forming or they are following a perfect manner or arrangement. Because of that, they are forming a three-dimensional network which is perfect and arranged in a particular manner. Existence of crystalline lattice. Now these crystalline solids, as they are forming a crystalline structure because of their particular arrangement or the perfect positioning of unit cells, so they are forming a crystalline lattice or the crystal lattice. Next, a crystalline lattice is a solid figure which has a definite geometrical shape with flat faces and sharp edges. Now these crystalline lattice is a solid figure, means these crystalline lattice are the form of solids which have definite geometrical shapes. Now we all know when atoms or molecules are arranged a particular shape or they are acquiring a particular position, they are forming a particular fixed geometrical shape. This geometrical shape are because of the arrangement of atoms or molecules, and because of this geometrical shape we can say the structure of these crystalline solids have flat surfaces, or these surfaces are known as faces in crystalline lattice, and sharp edges. Incompressible orderly arranged units. Now all the units which are arranged in an order or particular manner, they are incompressible because they are acquiring the fixed position and they have some force of attraction between them. So they are not compressible. Then definite sharp melting point. Now the melting point of these crystalline lattice is sharp, means high melting point they need to melt down. In the same way, high boiling point also they acquire. Anisotropy, definite geometry. These all are having definite geometry, the definite arrangement of atoms and molecules. Give X-ray diffraction bands. On diffraction by X-ray radiation, they are giving bands. Why? Because of these crystalline solid or crystal lattice they are forming, they are showing different bands of X-ray diffraction. Examples. Now, to consider the example of NaCl, CaCl, etc. These are the example of crystalline solids or crystalline lattice. Next one is amorphous solid. Now what is amorphous solid? Derived from Greek word amorphe, meaning sharpless. Now amorphous. So when we break the term amorphous, then amorphe, this term is come from the Greek nomenclature, and this amorphe means sharpless, means there is no sharp edges, or shapeless, means they are shapeless, there is no particular shape in them. So the term amorphous is come in the existence. No regular but haphazard arrangement of atoms or molecules. It means there is no particular arrangement of the atoms or the molecules in this type of solid. As we have seen in the crystalline solid, there was some particular arrangement of molecules and atom, but in amorphous solid there is no particular arrangement. They are mannerless, they are orderless, there is no arrangement among them. Also considered as non-crystalline solid or supercooled liquid. It means they don't form any crystal lattice or crystalline shape. As they are not arranged in a particular manner, so they are not forming any particular shape or geometry. That's why they are non-crystalline solid. They are not forming any crystal lattice, as well as they are supercooled liquid, means they don't have any sharp melting point. No sharp melting point. As we have just discussed, there is no sharp melting point. Why there is no sharp melting point? Because there is no particular arrangement of atoms or molecules. So there is no need of high or the lowermost temperature to melt down them or to boil them at high temperature. Isotropy. They are isotropic. No definite geometrical shape. Now, there is no geometrical shape between the atoms or the units of this type of solid. As we just discussed, there is no arrangement, particular arrangement or particular manners of unit cells. So that's why there is no particular geometry among them. Do not give X-ray diffraction band. As there is no particular arrangement of atoms or molecules, so obviously on diffraction of X-ray, no such bands of diffraction we can see in them, because no such diffraction takes place in amorphous solid. Examples: glass, rubber, plastic. Now we can see glass, rubber, plastics. These are the solids which are non-crystalline. They don't make crystal solid. They are stubborn, but they are we can change them or we can mold them from one shape to another shape, because there is no particular geometry among them. So now in the next picture we can see the arrangement of atoms or unit cells in crystalline solid and amorphous solid. The first picture is showing crystalline solid. Here you can see the arrangement of atoms are so particular. They are arranged in well manner. And in the second one you can see atoms or the unit cell molecules are arranged in randomly. There is no fixed arrangement of atoms. There is no particular manner they are following. So this is how you can differentiate them, the arrangement of atoms. So today this was all about solid state, the introductory part, the solid state, the arrangement of atoms, molecules in different state of matter, and also the types of solids, that is crystalline and amorphous solid. Now in the next session we will discuss something more about the solid state. Until, thank you.